All right, Courtney here again, just with question 2. One thing I forgot to mention about question 1 though is that we actually reached the first derivative, but that wasn't what the question was asking. It was asking for the first derivative when x is equal to 1. Literally all you have to do now is just plug in 1 into your equation of your first derivative, and that is it, okay? So that should be pretty straightforward. Question 2 is asking for the equation to the tangent of the curve y is equal to ex. That is perpendicular to 3x plus y equals 1. Okay, so really quick there, I just put this equation into the form when it's y equals mx plus b. Okay, just FYI. And what you're looking for, like this question is really here to kind of screw with your brain a little bit. It's asking for the tangent of the curve y is equal to ex. Okay, so you do know this though. So the tangent of the curve, what should you be thinking of when you think tangent to a curve? Like here's a curve and maybe I have a point here and I say, you know, find the tangent of this curve. You're going to draw me a line like this and you're going to state, oh, the tangent of the curve is like a line that, you know, doesn't cross the curve near that point. And you're right. Okay, so, but what is it actually asking you? Like, what is the tangent and what does that mean? So the tangent, you should be saying, is basically the rate of change at that point. And when you think rate of change, okay, rate of change, you should be thinking of a couple different things. Rate of change is equal to the slope, i.e. the rise over run, and is, you know, equal to the derivative as well. The derivative of the function also basically finds the rate of change of the function at a given point. Okay, just like how we found in question 1. Okay, so let's do this without further ado. So basically, we have this function here. So let's kind of do what we know, and then we'll deal with like the tricky things where it's talking about perpendicular to that equation. So the rate of change of this function, okay, i.e. the tangent, okay, so we know, okay, based on question 1 that the rate of change of this function is going to be e to the x, because obviously derivative e to the x is always e to the x, okay, no problem. Now it's asking it for it to be perpendicular. We want this rate of change to be perpendicular to this equation. Okay, so perpendicular, first of all, what does that mean? Okay, perpendicular basically means, like let's say I have a line here. Perpendicular would be, I don't like that line, we're going to change it. Perpendicular would be like this. Okay, meaning there is a 90-degree angle between the two lines, for example. So if it's asking me, and I'm going to draw this this line actually. So we get it, rate of change is equal to slope is equal to derivative. I'm going to erase this now. Alright, cool. So basically we have, let's have a graph here. Negative 3x plus 1. We start at plus 1 and our rise over run is negative 3 over 1. So we're going to go negative 3. 1, 2, 3 over 1. This is our line. Okay? And we want the tangent to be perpendicular to this line. So in other words, we want a tangent that is like this. Right? Or, I don't know, maybe it's up here. Right? The point is, it's perpendicular to it. Okay? So what we do need to find is the slope of this line and, of course, the y-intercept. Because that's the kind of the main problem, is that we know it's perpendicular, so it's going to be a line, it's going to kind of go like this at some point. Okay? But we don't know where. We do instantly know the slope, though, of this line. If you go back to your grade 9 notes, you'll remember that the slope of a line that's perpendicular to another line is equal to what? So, let's see if we can remember. So, slope of two perpendicular lines are negative reciprocals of each other. Okay? What the heck does that mean? So you might be having one of those moments where you're like, oh, right, now I totally get it. Or you might be like, oh, I don't remember what a negative reciprocal is. I'll give you a couple examples, okay? Let's say I have a slope of 2/3, okay? 2/3. The negative reciprocal of this one is negative 3/2. Okay, what if I had something like 7/5? Negative reciprocal is going to be 5/7 negative, okay? What if I had a slope of -3? What's its negative reciprocal? Okay, it's -3/1. Therefore, just literally make the numerator the denominator and vice versa, and you're going to get 1/3. Okay, that's what a negative reciprocal is. So right away, you can tell me that the tangent to this curve that is perpendicular to this line, it's telling you right now that the slope or the rate of change or the derivative at that point is going to be 1/3. Okay, sweet. So let's kind of get that together here. Okay. So we have this equation of a line mx plus b, which we want to find for this tangent. And we know instantly, okay, that the slope was 1/3 based on the negative reciprocal rule. And because we want it to be perpendicular to that line, x plus b. Okay, so great, awesome. We still need to find out what our b is. So how are we going to do that? Well, we're going to find out what y and x are at that point. Getting back to this derivative, because we know that the rate of change or the slope or the derivative at that point is going to be 1/3, how about I just plug in 1/3 in for our rate of change, or y prime? Let's do it. Okay, so 1/3 is equal to e to the x. Now what? Well, I do want to try to find maybe an x that goes into here, and then a corresponding y so that I can find b. So how about we isolate for x? I'm going to use this rule. Okay, and take the ln of both sides. Okay, and this will cancel out, right? Ln and e will cancel out, so I get x is equal to ln 1/3. Nice. Okay, so I can now plug that in for x. Okay, so I will go ahead and do that. And then I need a y. So perhaps maybe at the same time I can find out what our y is. How will I do that? Why don't we take our original function, plug in our x to find out what our y point will be. So original function is y is equal to, just going to draw a line here to separate the two kind of functions here. So y is equal to e of x, as we know, and instead of plugging in x, how about I just plug in ln 1/3. I'm just going to make it green just to kind of make it a bit more obvious, okay, of what's going on here. Going to plug that in there. Now I just, again, isolate for y, okay? We know that ln and e are going to cancel out. So literally you just have y is equal to 1/3. Okay? Sweet. We are almost there. Gonna make it blue. Okay? Sweet. Now, all we have to do is plug in our values into this equation to find out what b is. Okay? So that should be a no-brainer. Alright, so I'm going to do that. So pretend my equal signs are all one on top of each other. Oh man, I'm struggling. Okay, so I need 1/3 here. I have 1/3 in for our slope as we calculated via that equation. We took the negative reciprocal. We have ln 1/3 in for x, and of course we have b. Nice. Okay, isolate for b. Super easy. Okay, put everything to the other side, for example. So I'm going to have 1/3 minus, oh, did I screw it up? No, I didn't. Minus 1/3 ln 1/3. A lot of 1/3s going on. We are almost there. Okay, we have this. We have our y. We have our slope, okay, our m. We're basically good to go. At this point, I'm just going to erase everything just so I have more room to work with. So bear with me. I'm going to take everything away except for the b, because, and like the y and the x and all that. So I'm just going to kind of redo it all. Yeah, sure. Okay, cool. So here we go. Y equals, okay, sorry, at this point I don't need to plug in y or x because I have my m and I have my b. Okay, so I have y equals mx, so 1/3 x. We have plus 1/3 minus 1/3 ln 1/3. Okay, cool. And it just looks like in the answer they have everything on one side. Okay, looks like they just made it all equal to 0. So let's just move the y onto the other side. So I have 0 is equal to 1/3 x. It would be minus y plus 1/3 minus 1/3 ln 1/3. And of course you're like, okay, well it's not exactly the same as the answer, so what do I do? Well, what they've done is it looks like they just didn't like the 1/3, so they just multiplied everything by 3. And you can do that. Like, you can totally do that. Just multiply both sides by 3, like all of the terms, and you haven't broken any math rules. Okay, so obviously 3 times 0 is 3. 3 times 1/3 is going to be 1, so just get x minus 3y third plus 1 minus minus 1, so minus ln 1/3. Okay, we are almost there. You're probably looking at this and you're like, oh no, we're so close. We must have made like a mistake with like the ln 1/3 thing because it says ln 3, blah blah blah, and it's a plus. Like, what is going on there? Well, that is our key, okay? Because it is supposed to be a plus. So what we can do is we can remember the rules of ln, okay, which are really cool. Let's just say you had, for example, okay, so if you had like 3 ln 2, this is equal to ln 2 to the power of 3, remember? Okay, so I'm going to let you try one. So let's say we had negative 1/2 ln to the power of like 9. This is also equal to what, if I were to make this into an exponent? This would be equal to ln of 9 to the negative half, right? For example. Okay, so knowing that, we can change this one a little bit too. Okay, so I have negative ln to 1/3. So basically what I'm going to do is I'm going to take this negative 1 exponent and put it up here. Plus 1 plus ln 1/3 negative 1. And as we know, anything to the negative 1, right, you can literally just flip it around, for example, and then and make it to the plus 1. Okay, so y plus 1 plus ln this, because we know that, for example, 2 to the negative 1 is equal to 1/2. Okay, so we're taking the same kind of idea here. We're just flipping the numerator and denominator. We get 3. Okay, to the plus 1. And that is it for that question.